Okay, so I'm continuing on with the worksheet here. We're looking at how various objects in our solar system might have a big interrelation between if they're spinning, if their core is liquid, if they have a magnetic field, an atmosphere, and if they exhibit the phenomenon of the beautiful colors of auroras. And so we're working on it here. And we finally hit Mars. And so, yes, Mars is spinning. Remember, very similar to Earth, one time in approximately 24 point something hours. So it's very similar to Earth, but it is spinning. Okay, so as far as you know, Mars does not have a liquid core. It doesn't seem to be exhibiting any active geology like volcanoes or lava flows or anything like that. So there's a big no on there, and for that reason, Mars also has a big no on its magnetic field. And I would like to make a point about that no, because we have a question on our sheet of questions that discusses going to Mars, which is number 20. Which we've slightly going to get a better answer to here. I'll be more definitive about it soon, but it says, is going to Mars really all about building a big rocket, having food, shelter, and oxygen once there? But now you know that Mars does not have a magnetic field. And so what that means is that it doesn't have any protection from the solar wind. So my sort of base answer to question number 20 is going to be a big no. Because independent of food, oxygen, and shelter, you're getting hammered by the solar wind on Mars. In fact, Mars' surface is very sterile. For that reason, it would be very difficult to sustain life on Mars, and the answer to that hasn't really been forthcoming despite all the hype about going there. Okay, Mars has an atmosphere, yes. It's very thin atmosphere, but because of no magnetic field, you're not going to see any auroras. And maybe even if it had a magnetic field, the auroras might be hard to see, but there is probably a link then between the protection of the magnetic field and even having an atmosphere in the first place. It turns out the solar wind can just obliterate a planet's atmosphere, so the two might be related in there. Okay, Europa is one of my favorites. I have a question on there, question number 24. We're not going to answer it now, but why is Bensky so bummed about Europa? We'll get there. Europa is one of my favorites. It's actually a moon of Jupiter. And so, yes, it's actually spinning. So it's a moon of Jupiter. So, yes, it's spinning. It doesn't have liquid cores as far as we know, so no on that. But it is surrounded by a big salty ocean under a big layer of ice that it has. Okay, so salt. Salt is, well, minerals, sodium and chlorine and things dissolved. And so there is a good amount of charge in salt water. And so it turns out that it doesn't have a liquid core, but it has this ocean, which is salty and is spinning with the planet. So indeed it does have a magnetic field that, we think is generated, or scientists think was generated by that spinning salty ocean. Does it have an atmosphere? Yes, it does. Mostly oxygen, believe it or not. And so it does show auroras. So a moon of Jupiter does exhibit auroras. Okay. Then you get to Mercury, first planet from the sun. It is spinning. It does not have a liquid core. As far as you know, Mercury is geologically dead. There's no volcanoes, lava flow, anything like that. And so, does it have a magnetic field? Let's start with what letter you can draw? An N. But, surprise, 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 cross it out. Mercury does have a magnetic field, and it's not clear why. It might be because of something to do with Mercury is very rich, the most iron-rich planet in the solar system. So maybe there's something about that iron hanging on to a magnetic field maybe the planet used to have. But it's a little bit of a surprise there. So Mercury, put a star next to it. There's a surprise there with Mercury. It does not have an atmosphere, and so it wouldn't exhibit any auroras because that's where the colors of the aurora come from, the solar wind hitting the atmosphere. Okay. And so lastly, I don't know why I just put the sun on there, but the sun is sort of hard to even put in this category here. But I want to say, yes, the sun does spin, and the spinning, this word's getting a little too long to put in here, or right down there, is something called differential. Because it turns out that different areas of the sun spin at different rates, so it's all messed up in that regard here. I wouldn't go around necessarily claiming the sun has a liquid core, because basically the sun is sort of a big plasma, although there might be the high pressures deep within it, might keep some things liquid, but I just don't know. The magnetic field, yes, it has a very strong magnetic field. In fact, the sun is very extreme in just about all of these parameters here. And as far as an atmosphere goes, I really couldn't say. I'm not going to say that the corona is necessarily an atmosphere or anything like that, so I'm not going to go that far. And then the last question here, does it have auroras? I've certainly never seen any pictures of auroras on the sun. If there is anything like that happening, it might be too bright even to detect. But again, I'll just go with, like, look, the sun is a plasma. I'm not sure if auroras can appear in a plasma. I mean, all kinds of colors and stuff come out of the sun, as we know. But, whatever. The sun may or may not have been the best example you can put on this chart. So I will leave it with this. And I hope you can just look at this chart and go either just through any one of these rows and go in any order or even up and down and just see a whole bunch of logic and sort of connectedness between all of these things here. Like, you just go down and look at all the planets that exhibit auroras and wonder about them, or exhibit spin and wonder about them. And so I think this table is very informative, and hopefully every one of these Y's and N's makes sense to you in terms of all of that logic about where auroras come from, where the magnetic field comes from, why we would see the colors, all of that good stuff. So anyway, there you go.